Number 7 is saying that we have this side, whoops, we have this side QP is adjacent to TS. We have side RS is not adjacent, congruent to US. And what we're asking is that we want to give the values for X that would cause P to be larger than S. So I'm just going to write the two scenarios here. Angle P is greater than angle S. All right, so remember that this is reviewing the hinge theorem with you back from investigation 4. If two sides of a triangle, and I've marked the congruent sides, if two sides of two triangles are congruent to one another and the included angle is there as well, then it's the included angle that will dictate which of the opposite sides are bigger. In other words, if angle P is bigger than angle S, then that means that QR is going to be bigger than TU. So we want angle P to be greater than angle S, which means that we can state that 3x minus 6 is going to have to be greater than 9, according to the hinge theorem. If we solve for this, you'll see that we get 3x is greater than 15. So that means x has to be greater than 5 if angle P is going to be larger than angle S. But what about if angle P is smaller than angle S? Well, there's another scenario. This time we'll state that 3x minus 6, the side opposite angle P, will have to be less than 9. Again, when we solve, you'll see rather quickly that x is going to, this time, just be less than 5. But can x just be less than 5? Because that would imply that we could have a negative value for x, and that might not be the case. You have to, a side length has to have a dimension greater than 0. So to take that into account, we need to write another equation to make sure that we only include the values of x that will allow us to actually have a dimension that is greater than 0. So 3x minus 6 has to be greater than 0. When we solve for x in this case, we get 3x is greater than 6, and then we get x is greater than 2, which means that our final statement should look like this. X is less than 5, that's true, but it also has to be greater than 2.